So section 11.4, talking about volume. Again, the definition of volume is just the stuff that you can fit inside of a solid. Okay? It's the cubic units contained in its interior. And so, how are we measuring this? Well, let's step back for a moment. Remember that we had length. We can measure length simply by saying we have 1 unit. Right? That was measuring a length from there to there. I don't know if that's 1 inch, 1 centimeter, 1 mile, something like that. But we have a distance. That's length. Now, if I go through and want to start talking about an area, I then had to measure in 2 dimensions. Okay? I would maybe have 1 unit here, 1 unit here. And so then my area was being measured in 1 square unit. Okay, that is 1 square unit. And we've said that an area, we're then trying to figure out how many of those tiles we could fit inside of a shape. That was how we calculated area. Well, now we're talking about volume. Volume is 3-dimensional, and so we are taking our 1 unit by 1 unit tile, but then we're taking it in 3 dimensions. Oops. And so that is 1 unit by 1 unit by 1 unit. And so this is then 1 cubic unit. And so for volume, we're trying to figure out how many of those little blocks we can now fit inside of an object. That's the measurement for volume. Okay? Questions? All right. So if trying to figure out how many blocks fit inside an object, the nice thing is that whether you're talking about a prism of any type or a cylinder, the equation for volume is the same. The equation for volume is going to be volume equals base times height. Now notice the difference in this, and I've told you guys this a long time ago, that a variable is written the way it is for a reason. And so capital A stands for area. So please use capital A, not lowercase a. Okay? The area of a rectangle is base times height. The B and the H are lowercase in that equation for a reason. Okay, so please use lowercase b, lowercase h for base and height of a rectangle. Volume, all of a sudden we see base and height written as capital letters. We've already talked about capital H. Capital H stood for the height of a solid. Remember, that's why we used capital H versus lowercase h. Capital H was the height of a solid. Lowercase h was a height of a 2-dimensional shape. Triangle, rectangle, whatever the case is. Well, capital B now, capital B stands for the area of the base. Capital B is an entire area calculation. It's not just a length, okay? Capital B is an area calculation. And so looking at our diagrams then, capital B is that whole measurement of this base. What is the area of that base? Then you multiply it by the height, giving you the volume. Or the circle. What's the area of that circle? You multiply that by the height, giving you the volume. Okay? Questions on that so far? All right, well then let's go ahead and try a problem. So we have a right triangular prism. The fact they say right simply means that we have, other than of course in the triangle, the lateral distance, that lateral height here, is perpendicular to this height, right? The lateral faces are perpendicular to the bases. That's what a right prism is. We talked about that our first day talking about prisms. So we want to find the volume of this. We've already established that we're talking about a prism. And so our volume formula is capital B, capital H. Volume equals base times height. But there is a second step here. There is a second step. We need to plug in for the area of the base. What shape is our base? A triangle. And so capital B is the area of a triangle. Well, how do you find the area of a triangle? 1/2 base times height. Don't forget that we're then multiplying that times height. And so that is our volume formula for this triangular prism. Questions? So as you can see, yes, the volume equation is volume equals base times height. It's the same for all cylinders and prisms, but the formula is going to change depending on what shape your base is. If your base is a triangle, it's 1/2 base times height. If your base is a circle, it's pi r squared. If your base is a rectangle, it's base times height. Right? Okay, so let's go ahead and plug in. What is the base of the triangle? 3. Remember, base is always a side of the polygon. Height is sometimes a side of the polygon. And what is always true about base and height? They're always perpendicular. So then what's our height?
1.
Our height has to be 1. Okay, because those are the only perpendicular lengths they give us. And then we're going to multiply that by the height of the prism. And again, remember, the height of the prism is always the distance between the bases. So that has to be 2 in our case. All right, so make my life a little easy here. I'm going to take 1/2 times 2 because it goes away. 3 times 1 is 3. And so my volume is 3 cubic feet. Let's take a look at our second example. So we have a right cylinder. We want to find the volume. So what's our volume equation? Base times height. Remember, capital B is the area of the base. Well, our base in this case is a circle, so it's pi r squared times height. Okay, well, our radius is 5. So I've got pi times 5 squared times, and again, the height is the distance between the bases. And so in this case, that's a 6. So 5 squared is 25. 25 times 6 is 150 pi cubic meters. Questions? None yet. All right, let's take a look at the next one here. Next one's a little different. This time they're having us solve for the radius. X is the value of that radius. So the volume of a right cylinder shown is 1,253 cubic centimeters. Find the value of X. All right, well, how do I find volume of a cylinder? Volume equals BH. Okay, but wait a minute. Capital B is not going to be a number here. Capital B is going to be an equation, a formula. What do I plug in for capital B? Pi r squared. Because it's a circle. The base is a circle. Okay. So now I've got my formula written. I need to plug in for my variables. Okay? I'm solving for r. So I'm going to plug x in for that when I rewrite that, because that's what they're asking me to solve for, is x. That's my radius. Do I know the volume? Yeah, they gave it to us. The volume is 1,253. 1,253 gets plugged in for the volume. Then I have pi. Then I have x squared. Do I know the height? It's 10. Okay. So there we go. We've plugged in for everything we know, and now we need to solve for x. Looking at this, are we going to end up getting an exact answer on this problem? Probably not. I mean, we could represent it as an exact answer, but it won't be pretty. Okay? And so since we know that pi is involved, and we know that they gave us a whole number as our total volume, decimals are going to be allowed here. Okay? Decimals are allowed. So let's go ahead and round this to the nearest hundredth in the end. So what do I need to do first? Divide by, say it again. Okay, I could just divide by 10, but it'd make my life a little easier if I divide by 10 pi all at once. Remember, you got to be careful how you plug that into the calculator. So the pi cancels, the 10 cancels, and in my calculator I have 1,253 divided by, and then in parentheses, 10 pi. All right, what are we getting for that? Nobody else is punching buttons but me? There we go. 39.8842. And thank you very much for going out to 4 decimal places here, because we're working inside our problem still. Right? We don't want to round to our final answer until we're totally done. All right. So now how do I solve for x? I know what x squared equals. I've got to square root both sides. Yep. All right. So if I take the square root of 39.8842, and I want to round this to nearest hundredth. That's 2 decimal places. So that means x is approximately 6.32. Okay. Questions? I didn't forget the unit because they're asking for the value of x. X is a variable, so it's just a number. And that's the funky part in geometry. You got to be careful of the vocab, what they're asking for. If they say, what is the value of x? X is just a number. But if they say, what is the radius? Now we have units involved. Okay? And a good way of telling that is, notice up here, they already gave us the units. They said it's x centimeters. And so they just want, what is x? Okay? To the back side. Heading to the back side. Yeah, let's go ahead and let's have you guys try this one on your own. I'll give you, I don't know, minute 30. Ready, go. So in this case, we have a rectangular prism. And if I go in here and try to find my volume, remember, volume of a prism is base times height. And capital B is an equation. It stands for the area of the base. Well, the base is a rectangle. So base times height times height. But now here might come the issue. You might be saying, well, which side's the base? If you're finding volume, it doesn't matter. Remember back when we were doing surface area. For surface area, it mattered only if they asked us to find the lateral area. Because in lateral area, we had to know what the bases were so that we didn't include that in our lateral area. Okay? So that's the only time it mattered, is finding lateral area of a prism, rectangular prism. But if we're finding volume, it doesn't matter what you consider the base. Because if I say that the 11 by 4 is my base, then I'm taking 11 times 4 times 5. But if I said that the 4 by 5 was my base, that means I'm going to be taking 5 by 4 by 11. But what if I said the 11 by 5 was my base? Well, then I'm going to be taking 11 times 5 times 4. It doesn't matter in volume which one you consider your base. Because no matter what I do, 11 times 4 times 5, I get the same answer. Okay? Or if I take 5 times 4 times 11, I get the same answer. If I take 11 times 5 times 4, I get the same answer. Okay? So what is the volume of this rectangular prism? 220 cubic meters. Very good. Okay? Questions, comments? take a look at the next one. On this one it's very specific on what our base is. What's the base? I'm not looking for a dimension. I'm looking for an entire area. What side is the base of this prism? The triangle. The triangle is the base of this prism. And so when I'm finding the volume, base times height, I need to use the area of a triangle as my base formula. Okay? And so now I can plug in. My volume is going to be 1/2 times the base of my triangle is how much? What length? That one is 6. The height of my triangle is then 10. And the height of the prism, 5. The height of the prism is always the distance between the bases. And so I can take 1/2 times 6, which is 3. I can take 3 times 5, it's 15. 15 times 10 gives me 150 cubic meters. Questions, comments? Yes, sir. I know the triangle is the base because in a prism, if you go back and look at our previous unit, when we first started talking about prisms, I said that every prism has a couple of things in common. A prism is a prism because it has two bases that are parallel and congruent. Okay? Every single prism has two bases that are parallel and congruent. And I made that analogy saying that it's like the Play-Doh factory. You could use whatever the shape the base is, you put that as your slide or mold in front of the Play-Doh factory, and then you squeeze through the height of the prism. And so the bases are that mold shape, and then the height of the prism is how much Play-Doh did you squeeze through the mold. Okay? Well, looking at this shape, the only way to make it is if the triangle is your base. Because I have that triangle in the back, and I have a congruent triangle in the front. Those two triangles are parallel, they're congruent, and if I put that as a Play-Doh factory piece, I would be pushing through 5 meters of Play-Doh to make this shape. Okay? So that's making this a prism. It's a triangular prism because the triangles are the bases. Okay? Any other questions? No. Okay. Let's go ahead and let's try this one. Let's try this one. This one is called an oblique cylinder. We talked about oblique cylinders briefly when we first introduced cylinders and prisms. Okay? Remember I talked about this as being a deck of cards kind of pushed to the side, or a stack of DVDs or a stack of CDs that are kind of pushed to the side. The bases, in this case being the circles, the bases are still congruent and the bases are still parallel. Okay? They are still congruent and still parallel. The only difference is the height of this oblique prism is no longer the length of a side. The height of this guy is now going to be that perpendicular height between the bases. Okay, so that perpendicular height between the bases is now going to be outside of our cylinder. And so we need to do a little bit of math. In this particular case, we know that the hypotenuse here is 18. We need that long leg. They give us a 60-degree angle, so this must be a 30-60 right triangle. Okay, so here's our 30. If we do the quick shortcut, remember that it's 1, 2, square root of 3. The hypotenuse is 2 times the short leg. So that means this short leg must be 9. So our height must be 9 square root of 3. Going back to what we did back at Christmas time. Are they all going to be 30, 60, 90 triangles? No. Are you going to have to do Pythagorean theorem? Maybe. Maybe. Depends on what they give you, right? Sometimes they'll just give you the height of that oblique prism or that oblique cylinder, depending on the case. But the cool thing is about these is it doesn't matter if they're oblique or if they're right. The volume formula is the exact same. So we still have pi r squared times height. And so our radius is going to be what? 6. They gave us a diameter of 12. And our height, we found out, is 9 square root 3. Okay, let's go ahead and round this to the nearest hundredth. So I can go ahead and plug that into my calculator right now. I'm going to take pi times 6 squared times 9 times the square root of 3. And so we should be getting 1,763.01 cubic millimeters. Okay? Questions? All right, I've got one more example for you guys. One more example right here. We have that composite figure. What is this composite figure made up of? In fact, we've seen this exact same figure before in previous examples, previous worksheets. But now we're finding volume. So what is this composite figure made up of? Half of a cylinder and a cube. And this time we actually want to think of it as half of a cylinder and a cube. I don't want to think of it as a label and a circle because I'm not doing surface area. I'm doing volume. Okay? There is no label in volume. All right? We just want the amount of stuff inside. So we're going to say that we have a cube. The volume of our cube is going to be base times height plus half of a cylinder. So that means we want to take half of base times height. Obviously, we're not done. We got to plug in for capital B. Capital B is always going to be an area formula. So the base of our cube is a square. How do you find the area of a square? Okay, so we have base times height plus 1/2 times the base of our cylinder. What's the base of a cylinder? Pi r squared. Be careful. Right here is where people make mistakes. Please make sure you are listening to me right now, 100%, not every other word I say. People will make mistakes here. How much of a cylinder do we have? Half of a cylinder. We have already established the 1/2. So now we need to be thinking of this as if there is a full cylinder sitting there. And what's the area formula for the base of a full cylinder? Pi r squared, a circle. Okay? A lot of times people look at this and say, well, it's half of a cylinder. What's the base? What's the base formula? Say, oh, it's half of a circle. And they put too many 1/2s in there. Okay? You have already taken 1/2 of the cylinder. You do not want to do it twice. Understand what I'm saying? Making sense? Okay. And so, let's plug in. Volume equals, well, we got 4 by 4 by 4 plus 1/2 pi. What's the radius of our circle? 2. Excellent. So we have 2 squared. And what's the height of our cylinder? 4. The height is that distance between bases. Excellent. So we have 4 times 4, which is 16. 16 times 4, 64. Plus 1/2 times 4 is 2. So 2 squared is 4. 4 times 2 is 8. And so 64 plus 8 pi cubic inches is our exact answer for this shape. Questions?